Howdy, everybody. I just wanted to do a quick update on my advent of code in the Haskell land. I got some cool user input, and I wanted to just talk about those. And I also finished up part one of day 4, which was yesterday. So I'm still behind with the Haskell stuff, but I'm making progress and wanted to, for the people that are interested in the Haskell stuff, here it is. So let's just get right into the code. First of all, I just wanted to thank a couple of the listeners or watchers or whatever you call them. First of all, Luke had a really cool comment. He mentioned that this chunks function I was using is actually exactly what the standard library tails does. So maybe I can show you what that looks like. You can see here it essentially does exactly what I did, right? I guess this is a little bit hard to see. I'll zoom in a little bit, but it essentially does the exact same thing that I was looking to do, is break them up into this. That way I could check each of the pieces. So if I go back to my code, right here, instead of calling that chunks function on the first digits, I can just call tails, and then I can check to see if the first one is a digit for each of those as I'm iterating through it, if that makes sense. Interesting enough, though, I found another cool comment that I may not even have to use any of this stuff. It was Flying V for Vendetta. He had mentioned that for part 2, I could actually do a string replace, which in my video, I think if you remember, I was trying to work around a string replace, but there's this issue with overlapping numbers. 1 and 8 could technically overlap, and you'd want both 1 and 8 to be in that list, because 8 could be the last and 1 could be the first. But if you just replace the 1 with the letter digit 1, you now have an IGHT, if that makes sense. Because of that overlap. He had mentioned that it's really only the end characters that overlap. So you could actually do something like this replace string digits, which this may not be great Haskell, but the idea is, what if you just went through the string and took a 1 and did it like this? So if it happened that there was an 8, you would be able to do it. It would still have a 1 and an 8 in the correct order. So if I call this right now over here on the right hand side, and I do like this, actually without the E, right? So they overlap. I still get the 1 and the 8. And so having done that, having this function do that is a little complicated, but basically I create this list, and because I'm doing the text replace I'm going to do a text replace of all of these, so I have to pack them and then unpack them. If anyone has an easier way to do all this, I would love to hear that as well. But basically I just do a fold L for the original string on all of these replacements, and that then turns them all into this, and then I can just use the original part 1 to do it. So if you look, this part 2b, which it produces the same results as part 2, but instead of doing that other work where I have some special filter, I can still just filter by is digits and then pick the first and the last. All I have to do before I do that is take all the calibrations and apply replace string digits to it. So I thought those were some really cool user input. I always like to learn about these things. Both of them are, I think, key things in a learning process, like I'm learning Haskell. The first one being, sometimes you just don't know about a function in the standard library, right? If you imagine all of the tools that are in the C++ standard library, Rust is getting that way too. It's not even close to C++, but Java, they all have these standard libraries. Python, I could list them all, right? they all have these standard libraries that do a bunch of stuff, and you may just not know about it, and so you re-implement it yourself. So part of the learning process is knowing what's in the standard library and available to you. Some of that just takes time and experience. And so it was really cool to learn about the tails function. So when you're going through this process, if it doesn't hurt, and I probably should have done this, is Google hey, is there already a function in the standard library that does this? And you might have found something, right? The other thing is, when you're thinking about solving problems like this, thinking about the bounds of the input criteria, the input text that you're receiving, is actually important, right? I think you don't think about it initially, but when you're looking through this, you kind of realize, if you look at the replacements that you'd be making down here, excuse me one second. Sorry about that. If you were looking at the replacements you were making down here, you would see that, oh, they would never overlap more than one letter, right? Like the beginning of one never goes further in to one of the other. And that can simplify your algorithm. So it's something that you don't always think about, but spending some time looking through the data can help. And obviously these are just fun projects, but it is an interesting reminder that, hey, I can, if I spend some more time in analyzing the data, I might be able to gain more insight into it. And when you're actually doing interview problems, that will sometimes be the case, right? I think I've seen, it was a question from Amazon or Google where they're trying to get you to calculate the tension of a rope that is a given length and on two poles, and they give you the dimensions and they want you to calculate this. You may struggle because you're like, oh, how do I measure the tension? How do I know its position and stuff? Unless you look at the parameters and you realize that the only possible way for it to work is if the two poles were directly adjacent to each other, and so the rope was actually strictly touching the ground. And you just wouldn't notice that if you were focused too much on what is the problem, or how do I solve this problem generally, versus how do I solve this problem with the inputs that I'm given. And I think, but again, this is a kind of a cool way to solve it. Thinking, instead of thinking just generally, how do I solve this, given the constraints I have, is there a simpler way to solve it? And this happened to be it. So that was the two user inputs. Just a reminder, I enjoy improving, and so if you have thoughts or ideas, I would love to look at them, maybe even try and implement them like I did these ones. I think I've done it with other people too. In the Rust stuff, people have said, oh, you could do this or try this, and I've made those changes. I don't know that I mentioned them, but just again, I'm very grateful for everyone taking time to watch the videos and then to give input so I can learn and to grow. And I'd like to do the same too. Like, if you have a solution, I know it's hard to give the solution in the comments, but maybe even if you just give like the ID of the gist or whatever, I'd be happy to look at it, and we can even do some compare and contrast there. So more into the Haskell land though. If I go to day 4, I actually did end up implementing this in Haskell because it wasn't too hard now that I was aware of parsec. Again, just a reminder of the problem. It was just yesterday, but maybe you haven't seen the video. Maybe I should do the test input. The idea is you have these sets of cards, and these are winning numbers. These are the winning numbers of the cards, and these are your picks. They're like scratch cards, lottery type things, if you're familiar with them. And the idea is you're trying to calculate how many of your picks are winners for this card. And when I implemented it in Rust, it was quite simply just a set theory problem, right? You're just doing an intersection of the two sets of numbers, and from there you can calculate your score, right? So because it was very set oriented in nature, and it felt like there was like a pretty clear way to do this in Haskell. Although I don't know that when I say that, I mean, I'm sure there's different ways to do it. It's just it felt natural to me to do it this way, and Haskell felt like it would be relatively easy to solve it as well. So I did that last night while I had a few minutes, and I'll just show you the answer. Again, it's kind of similar to how I did it in Rust. I create this card with the list of winning numbers and the list of R numbers, and those are at sets, right? I used parsec. In Rust, I had used nom, which is an equivalent combinator parser. And I would be interested if anyone's familiar with the parsec tool. How might you do this more simply? There's a couple times it says it was saying use this operator, and forgive my ignorance, but I actually don't know what this is. It looked like it was some kind of logical combinator or logical combiner of these things. Yeah, see there, it's popping it up again. It says, oh, you can use this. I will have to study more, or I'd love to hear from you guys. Maybe you can just explain it to me how to use that. But essentially, I'm just parsing the card here with parsec. And the way that I do that is I say, oh, there's going to be a card, there's going to be some number of spaces, then there's going to be the card ID, a colon, some number of spaces, and then I want you to parse a list of ints, and then that's separated by a pipe, and then our points our picks are another set of ints, right? And so from that, I can derive a set of winners and a set of R's. So the parse ints and the parse cards are pretty similar to what I've done before, where you just kind of implement this parser to like handle the input. These ones felt pretty easy. It's this one that I felt like, oh, is there an easier way to do that? Maybe I'll research that more. But then once you have the cards, part one is actually really simple, right? You want to do an intersection of the winning numbers and your own numbers, and then based on that, you can just do a bitwise shift of the number of wins you had, right? Obviously, if you have 0, it's 0. Otherwise, you're just going to shift that number. If you remember, the solution was you're doubling it each time you win. So if you win once, you get 1. If you win twice, you get 2. 3 times, you get 4. And that's a bitwise shift, right? So I just used the shift operation to do that, and it gave me this solution. I have not done part 2 yet. I didn't have time to try and implement it. It actually feels like it may be harder because you're tracking state. The way it changes is instead of your points being awarded based on how many wins you got per card, it's now every time you win, the following number of cards are duplicated for each time you win. And so that in Rust, I did this like duplication logic where you're tracking state of like wins as they're going through, because winning 2, 3, and 4 doubles them, but if you win 2 twice, now you're doubling 3 again, right? And so you start to get huge numbers down there. And so it was easy to track that state in like a vector or a map, for example, a list, that type of thing. I don't know how you do that in part 2. I know there's a state monad, but I haven't even looked at it yet. That's how early I am to Rust. Again, I'm literally like week 2.5 of Rust, of Haskell. I've only been doing Haskell for 2.5 weeks. The state monad might be a great way to do that. If you have your solution in Rust, I'd love to see it, because maybe, especially for part 2, maybe you don't need the state monad. Maybe there's some way to track those values as you're incrementing it. Or, again, a lot like thinking about solving the problem with the conditions you're given, maybe there's some mathematical way that you can track this that would work quite simply functional in like Haskell or some other, functional language. I'd really be excited to hear your inputs, especially if you can do it in like a very functional type way, maybe using monads would be interesting, because sometimes I feel when I solve these problems like this, it doesn't feel very Haskell-like, or it doesn't feel very functional, if that makes sense. I realize that there's just some things that you need to use monads for, but sometimes this doesn't always feel like a very functional solution, even though it's part of Haskell and you are using, the Haskell language to solve this. But anyway, those are my rambling thoughts about it. So there's my day 4. I did get it done in Haskell. I really do want to keep finishing him in Haskell. I think I'm just going to keep doing him in Rust first, but I will try and finish him in Haskell. I took the rest of the week off from regular work. Part of that was because I have family obligations, so I may not be able to get as much done as I want to, but hopefully I will have more time to do the Haskell stuff, and you guys will be able to see those solutions, and then and I'd love to hear from you on the solutions you've had. I like to go into the problems blind, so don't send me. I mean, I will just ignore any solutions you send me for days that I haven't done yet. But obviously, I truly am interested in hearing how you guys solve these problems and any optimizations or simplifications that you guys have for me. So thanks again for all of that. And I'll say goodbye to you. Have a great day and have fun coding.